Hello, in today's video we're going to be going over rate law and rate orders and how to determine what the rate order of an individual reactant is and the overall reaction. So rate law, the equation is rate is equal to K, which is the rate constant, times the concentration of reactant A to the M, times the concentration of reactant B to the N. And it's standard to use the reactants in the rate law. Now, what are each of these numbers? So K, like I mentioned, is the rate constant. M is going to be the order of the reaction rate for compound A, and B is going to have N order for its reaction. Now, what do the orders for them mean? So if you have a 0 order reaction, that would mean that your rate is equal to K times the concentration of A to the 0. And we'll just assume here that there's just one reactant, A. Right, you can have however many reactants you have in a reaction. Generally, it's not more than 3. It's pretty standard to have 1 or 2, but you can keep going. You could have concentration of C to the, you probably won't use the O power because that would look like a 0, so you could say like the P power or something. So for a 0 order reaction, rate is equal to K times the concentration of A to the 0th. And if you remember from math, anything raised to the 0 power is 1, which means that the rate is simply equal to K, the rate constant. This means that the rate of reaction is independent of reactant concentration. So the rate is simply going to be whatever the rate constant K is, and it won't change from that. Now the units of K are important. They're going to be different depending on what the overall order of the reaction is. Rate is expressed as the change in concentration over time. So that means for rate, the units are generally in molarity or molar per second. For a 0 order reaction, since rate is equal to K, that means the unit of K is going to be molar per second. The next order you can have is a first order reaction. And in a first order reaction, your rate is equal to K times the concentration of A to the first, which is going to equal K times the concentration of A. In this case, right, your rate of reaction is proportional to the change in the concentration of A. So if the concentration of A decreases by half, your rate will decrease by half. If the concentration of A triples, your rate will triple. And then the units of K here, because the unit of A is molar, and you're trying to get molar per second, the units of K are going to equal just per second. Because you get the molar from A, and then the per second from K. A second order reaction your rate is going to equal K times the concentration of A squared, right, which would equal K times the concentration of A squared. So that means for this, the rate of reaction is not necessarily 2 times, is the change in the concentration of A raised to the second power. So if my concentration of A doubles, the rate would quadruple. And the units here of K are going to equal inverse molar inverse second. Because if I'm squaring A, that means my units of A are technically molar squared. Because I have molar and molar together makes molar squared. So if I'm going to end up with units of molar per second, I need to have inverse molar inverse second as the units of K. So in the next video, I'm going to go through an example of looking at experimental data and a table of rates, time, and concentrations to determine the reaction order from that data. Because that is the only way you can determine the order of a reaction is through experimental data. See you then.